I'll just do it from here. It's fine. Okay. Introduction. Sorry, guys. Heat waves have become an increasing threat to public health, infrastructure, and economies worldwide. India, in particular, faces heightened risks due to its high population density and climatic conditions. Unlike traditional heat waves, humid heat waves measured using wet bulb temperature, WBTs, can be even more dangerous because they reduce the body's ability to cool itself through sweating. In this study, we analyzed trends in humid heat waves from 2001 to 2022 and their correlation with heat-related deaths across Indian states. We also examined the role of population density in exacerbating heat wave impacts. Our findings highlight the urgent need for targeted interventions and urban cooling strategies. The key objectives of our studies are, firstly, we aim to identify trends in humid heat waves and heat-related deaths in India. We also assess the correlation between heat wave intensity, frequency, and mortality rates. Thirdly, we investigate the impact of population density in amplifying heat-related risks. Finally, our goal is to provide actionable insights for policymakers to implement effective heat mitigation strategies. For data sources, we relied on a couple of we used temperature and dew point data from ERA5 reanalysis dataset to calculate wet bulb temperature. Population density we obtained from UN data portal, population division. Heat-related mortality data was sourced from the Indian Open Government Data Platform. We also used geospatial data in Indian state boundaries to conduct regional analysis. And by combining these datasets, we developed a comprehensive view of the relationship between heat waves, population exposure, and mortality. Now let's discuss how we conducted our analysis. First, we calculated the wet bulb temperature using ERA5 reanalysis data. We defined we defined heat waves as any 3-day period where the daily WBT exceeded the 90th percentile for 3 consecutive days for a given state. So we used sort of a sliding window analysis to get the number of heat wave days. We aggregated the data to the state level and computed annual averages for trend analysis. Lastly, we examined the correlation between heat wave frequency, intensity, and heat-related deaths with specific focus on population density. Long-term trends in heat-related deaths. Our results reveal a concerning trend. Heat-related deaths have been increasing over the past 2 decades, as we can see from the blue line, which is the mean. The trends correlates with rising global temperatures and more frequent heat wave events. As shown in the graph, both the number of heat-related deaths and the overall trend line indicate a growing public health crisis in India. These findings highlight the urgent need for effective adaptation strategies to reduce mortality risks. Heat wave frequency and
Alind, I can take over.
oh,
I'm
sorry.
here.
Oh, yeah.
Yeah, sorry. We also examined the correlation between the heat wave frequency and heat-related deaths and found out that there is a moderate but the significant relationship. While higher heat wave frequencies tend to correspond with the increased heat-related deaths, the relationship is not perfectly linear. Other contributing factors such as humidity, urban heat island effects, and also the socioeconomic vulnerability that likely influence this correlation. Next slide. Um, So our findings indicate that simply counting the heat wave days may not fully capture the risk. So with this in mind, we explored the contribution of population density to heat-related mortality. The graph shows the heat wave frequency, heat-related deaths, and population density over time. Areas with the high population density are particularly vulnerable due to the urban heat island effect and the limited access to cooling resources. Next slide, please. Now let's talk about an important anomaly that we observed during our analysis. In 2005, West Bengal recorded the highest number of heat-related deaths, despite experiencing relatively few heat wave days, indicating that non-climatic factors may have played a significant role. In 2015, there was a sharp rise in heat-related deaths in Andhra Pradesh, Uttar Pradesh, and Telangana, possibly linked to an extreme event or preparedness issues. By 2019, the heat wave impacts had spread geographically, particularly affecting the Bihar, Maharashtra, and Punjab. Can you go to the next slide? Yeah. So from our findings, several key insights emerge. Firstly, the socioeconomic factors, infrastructure disparities, and public health interventions significantly influence heat-related deaths. The disproportionate impact observed in certain states highlights regional vulnerabilities that require tailored strategies. Also, the increasing geographic spread of the heat wave impacts suggests that the new areas are becoming vulnerable over time. And also the effective mitigation measures, including improved cooling infrastructure, early warning systems, and policy interventions are essential. Now let's move on to summarizing our conclusions. Next slide, please. The study concludes that HRDs, heat-related deaths, have generally increased over the past 2 decades, primarily driven by rising temperatures and heat wave frequencies. The population density and urbanization contributed significantly to heat-related risk, particularly in the states like Andhra Pradesh and Uttar Pradesh. Also, the tailored interventions such as early warning systems, cooling infrastructure, and public awareness campaigns are critical to reducing heat-related deaths. The findings provide a basis for developing targeted policies and strategies aimed at reducing the heat vulnerability and building resilience. Next slide, please. We propose several avenues for future research here. Firstly, evaluating the effectiveness of heat action plans implemented by various states, conducting microclimate strategies using the remote sensing data for high resolution mapping of heat risk. Then developing machine learning models for predicting heat waves and assessing their potential impacts. Investigating the role of afforestation and cooling shelters as adaptive strategies to mitigate the heat stress. And these efforts aim to enhance the robustness and accuracy of heat vulnerability assessments and inform better policy decisions. Next slide, please. Yeah, so before concluding, we would like to acknowledge our mentors, Daniel and Kenny, and also the Impact Scholar Program for their support. Thank you.